Alright, today we are going to start the part of our unit where we look at verifying trig identities. So trig identities, that's something that we already know. We have learned all of these identities. I did post, oh, sorry for the craziness. I did post this as a PDF up on our Google Drive and everything, so it's something that you can take a look at. You can print out if you need to. You can write them down. You should have them all, but they're kind of all in one spot here. And now we already know that all of these identities are true. We've actually gone through and verified a lot of these identities and gone through and kind of proven what it actually was. So these are some of our identities. But what's actually true on these is these are also identities. Now, they're not things that we would expect you to memorize, but what it's saying is that the left-hand side is equal to the right-hand side. And our goal is going to prove how those two things are actually equal to each other. So we're already assuming that they're equal. We don't need to solve for x. We're not trying to find out what x actually is, but we're saying really what we want to do is go through like step by step to show how one side equals another. So just to kind of show you what I mean in a non-trig kind of way here, if I were to give you something that looked like this. So you did this way back in middle school, and you would actually know that this is equal to 38. So this is a true statement. This is something that we know is already true. But what I want to do is show you what we mean by the verifying step. So when you do verifying of these identities and so forth, you really only want to deal with one side at a time. You're not allowed to treat this like an equation where you want to, like multiply both sides by 2 and so forth on here. You actually want to go through and only work with one side and really go part by part. So you actually have to show your full steps. Now, some of them you may want to say, well, I know 6 minus 4 is 2 times 3 is 6. I want to do that right away. But when you're verifying the identities, you actually have to go part by part. So we would do order of operations for this one. So that means we would do the parentheses first. So again, notice that I would show that full step. Okay, and then I'm going to leave the right-hand side kind of by itself. I'm just going to look at the left-hand side here. So now, order of operations says that we do our exponent step first. So again, I'm going to leave this, and we're going to do the exponent part here first. Now we know that we have to multiply or divide in order from left to right. So that means I would actually do that part first. And then we know that this is true. And now when we get down to it, now I can finally prove the addition right here and say that, yes, that's 38. All right, that equals that whole side of 38. Yes, it's true. I verified that this is true. So that's really what we mean by verifying. It's actually going through and showing your steps. So we're going to do the same thing with these trig identities. So again, really you're going to pick one side of this identity. You're only going to deal with that one side. Again, I can't like subtract cosine over to the other side. I can only deal with one side. Now, reasonably speaking, you could pick either side. Typically, you want to pick the side that looks maybe a little bit more complicated. You'll see in a lot of these here that the left-hand side is actually what we're going to be really dealing with. Technically, though, you really could pick either. So I'm going to look at this left-hand side. So I'm going to actually just start by writing that left-hand side out so we know which one we're looking at here. Okay, so we've got that left-hand side. We know that that's equal to the secant of x. So now we want to think about how we can prove that that's actually equal to the secant there. So we want to somehow try and get it into one thing. Right now we've got a lot of stuff here. So try and maybe sometimes get it in terms of, just one or two actual trig functions here. So I know that I can change the tangent by our identities into the sine over the cosine. So that's going to be my first step of just kind of going through and writing in some things that I know. So now I'm going to keep working with this left-hand side. If I'm multiplying here, I can now say that this is sine squared over the cosine plus the cosine. Notice I haven't touched the right-hand side here, okay? So again, now we want to keep going. Our goal, kind of keep our end goal in mind. Our end goal is to get it to equal the secant of x here. So we know that we don't want any pluses or minuses. That means I'm probably going to want to add these together, which means I need some common denominators. So I can multiply. Now I can't, multiply both sides, or I can't subtract the cosine or anything. I can only deal with this side. So we can only do things that would be equivalent. But if I multiply numerator and denominator by the cosine, that's really multiplying by 1. That doesn't change it. So that will get us some common denominators. I'm going to rewrite this part. So that gives us cosine squared over cosine. Now that we have common denominators, now I can add together that numerator. Okay. And maybe you can start to see things forming here. Now you can look and say, oh, wait, this sine squared plus cosine squared, that should stand out. That's an identity in and of itself. That is equal to 1. Now, look, we have 1 over the cosine, and yay, conveniently, 1 over the cosine is the secant. And that now equals that other side that we wanted it to equal here. That equals the secant, and we just verified this identity. So again, you'll notice I only dealt with the left-hand side here, and we go part by part, and you do have to show your steps. You're fully showing a proof. I kind of think of these almost like a puzzle. It's kind of like once you get used to them, some of them are challenging, some of them are a little bit easier, but they can be kind of fun to go through and try and manipulate it. And again, there are a lot of times different ways to go through and prove it. So when you start to look through some of my answer keys, you'll start to see like maybe, oh wait, I did it this way. And a lot of times that's okay. There are different ways to go about these here. Like really, I could have changed this sine squared up here into 1 minus the cosine squared. That would have been an option. Then you would have combined them together and so forth. So there are different ways to go and do this. But again, you do have to show all your steps. So those of you that like to skip steps, you can't on this one. Part of the verifying is showing that steps there, those steps. All right, let's try another one here. So again, I'm going to look on the left-hand side. I'm going to give myself some room here. I'm going to start over here. So the cosine of theta, I'm just going to rewrite what we have. Again, we like to do that when we're doing these, since these are really proofs. We're not doing like a, geometry 2-column proof, but we are going through and saying, okay, that is my left-hand side. That's where I'm starting. So our goal is to get that to equal 2 secant theta. So again, when I look at that, I kind of see the right-hand side doesn't have any pluses or minuses. So my first thought really is let's try to add these together. To add them together, common denominator we need. So that means I'm going to have to multiply this fraction by 1 plus the sine, plus the sine of theta in our numerator and denominator. Over here, we're going to have to multiply by the cosine over the cosine. So that gives us cosine squared over cosine times 1 plus sine. And then plus, this is going to be 1 plus sine times 1 plus sine, or 1 plus sine squared. Okay, so let's multiply them all the way out and everything here. So we can now add them together as well. So I'm gonna write, all right, that's the cosine squared right here. Plus, I'm gonna multiply this all the way out. That's 1 plus, that's gonna be sine times, or the sine plus the sine, so 2 sine, and then plus the sine squared. And again, all of that is over the cosine times 1 plus the sine. Now I could multiply that out. I'm going to leave them separate right now since there's 2 different trig functions, since it's a sine and a cosine. I'm going to kind of leave those separately there just to kind of keep them different. We may have to multiply it out at the end. All right, when I look at this, I see some things that I'm going to kind of group together. So I'm just going to rearrange this to put the cosine squared and the sine squared together, and you might notice that we have, I can finish writing this here, we've got the cosine squared plus sine squared. We know that that whole thing is equal to 1. So that means I have 1 plus 1 plus 2 sine of theta. Again, you'll notice I'm kind of taking my time and showing my steps. Really, I should be kind of putting some equals down after all of these here. Okay, so I'm going to combine these together. That means I have 2 plus 2 sine of theta. Okay, I'm running out of room, so I'm just going to move some of this up over here. So, okay, I have my numerator, I have my denominator. Again, kind of think about, is there any way that we can reduce this? What can I think of? What can I go through? Do I see anything that's sort of similar? And in that numerator, I see a 2 plus 2 sine of theta. In the denominator, I see 1 plus sine of theta. So if I think about it, I can factor that numerator. I can take out that common factor of 2, and I'm left with this. Okay, and now we've got a 1 plus sine of theta and a 1 plus sine of theta. Those cancel, and I get 2 over the cosine of theta. And we know that the cosine of theta is really, here I can rewrite it this way, as 1, the cosine of 1 over this is really, let me write it like this so I can explain it here. If I think about it like this, that's really 2 times the secant of theta. And that was our ultimate goal. We wanted it to equal 2 secant of theta on the other side, so we verified it. So again, these aren't all about getting one right answer. There's no like solution on these. Really, it's about the process. It's about going through and showing all of your work, showing your steps. Some of them are quick, some of them take a little bit longer. Go through and think about all of the identities and kind of play with them a little bit. You might take a longer route than me sometimes. Maybe sometimes you'll find a faster route. It just kind of depends on which identities you pick and which ones you go through. Again, there's not always just one way to do it. But the main idea is that you go off of one side of that identity and really work with it, manipulate it, and see if you can get it equal to the other side. So you've got a couple more to work on. I'm going to leave you to work on these on your own. And then there's a couple of review problems. Notice these are calculator problems, just to kind of go through and keep practicing some of those things that we did before spring break. Okay, thanks. Bye.